Hey there, and welcome to this explainer. Ever wonder how your phone processes all that data without a single glitch? Or how architects manage to design those perfectly curved, swooping buildings? Actually, even stuff like measuring land for a new house or calculating those crazy layered shopping discounts, it all relies heavily on the math of polynomials. I know, right? So today, we're going to demystify polynomial division, step by step. Now, if looking at a page full of algebra makes your heart race, just take a deep breath. Seriously, act like I'm your personal tutor sitting right next to you at the kitchen table. By the end of this session, we're going to take you from feeling anxious to absolutely confident. All right, let's dive right in.
Okay, here's our quick roadmap for today. 1. Visualizing zeros. 2. Logic before formula. 3. Level 1 basics. 4. Level 2 standard form. 5. Our Level 3 board exam challenge. And finally, 6. A quick cheat sheet.
Section 1. Visualizing zeros. Seeing the math first. Now, before we look at any intense algebraic formulas or start, shuffling letters and numbers around, let's just picture what a polynomial actually is. Visualizing the shape of the math first, that is the secret to true understanding. The term zeros of a polynomial sounds super intimidating, I get it, but as we can see from our source material, they're literally just the exact points where the graph crosses the horizontal x-axis. That's the whole shebang. It's just an intersection point on a map, nothing scary.
Just think about the shapes. A linear graph, well, that's a straight line, so it crosses the axis exactly once. A quadratic graph looks like a big U shape, right? So it can dip down and cross the axis up to 2 times. And a curvy, wavy cubic graph can cross it up to 3 times. Once you see these shapes in your head, the numbers start to make total sense. Let's see how this builds our foundation for division. Moving right along to Section 2, Logic before formula. The true foundation of division. All right, before I throw long division with variables at you, let's look at this simple, beautiful logic that makes the whole process work. It's really not just about how to use a formula, but why it actually works. Think back to primary school. If you divide 7 by 3, you get 2 with a remainder of 1, right? That simply means 7 equals 3 times 2 plus 1. And you know what? Whether you're dividing simple numbers like that or massive, scary-looking polynomials, this foundational word equation always holds perfectly true. The dividend is what you're breaking apart, the divisor is what you divide by, the quotient is your answer, and the remainder is just what's left over. And this brilliantly illustrates the formal mathematical version of that exact same concept. The algorithm simply states that for any polynomial p of x divided by a non-zero polynomial g of x, we can find a quotient and remainder following that exact same basic rule. See? It's the exact same logic you already know and love, just dressed up in algebra. All right, Section 3, Level 1 Basics. Time for Example 8, your very first step. Let's tackle our first example together. Here's our Level 1 problem. Let's read it. Divide the quadratic polynomial 2x squared plus 3x plus 1 by the linear polynomial x plus 2. Okay, so what's given? Well, we have a U-shaped quadratic dividend and a straight line divisor. And what's asked? We need to find the quotient and the remainder.
Now, just like a private tutor, I want you to adopt this simple mental checklist for every single problem you face. Ready? First, identify who is who. Second, just focus on the biggest terms. Divide them, multiply back, subtract, and then repeat. It's just a rhythmic cycle. Let's apply that checklist right now. We look at the highest term inside, which is 2x squared, and divide it by the highest term outside, which is x. That gives us 2x. Then we multiply 2x by our divisor, subtract, and bring down the next term. Notice how we elegantly stop dividing when the remainder's degree, in this case just the number 3 without any x attached, is smaller than the divisor's degree. So we're left with a quotient of 2x minus 1 and a remainder of 3. Beautifully simple, right?
Okay, Section 4, Level 2 Standard Form. Let's look at Example 9 and avoid some traps. You totally crushed Level 1, so now for Level 2. Let's read our next challenge. Divide 3x cubed plus x squared plus 2x plus 5 by 1 plus 2x plus x squared. What's given? A cubic polynomial dividend and a, well, kind of mixed up quadratic divisor. And what's asked? Again, quotient and remainder. But hey, take a really close look at that divisor. Do you notice anything a little awkward about the way it's written?
Yep, the crucial point is right here. The absolute most common mistake students make in exams, like the trap that literally costs them easy marks, is forgetting to rearrange terms into standard form before they even start dividing. always put the highest power of x first and work your way down.
By first safely rewriting the divisor as x squared plus 2x plus 1, we protect ourselves from making a total mess. From there, the division flows super smoothly in 3 clear steps. We divide the highest term, 3x cubed, by x squared, giving us 3x, multiply, subtract, bring down the next terms. We just repeat that cycle until we hit a final remainder of 9x plus 10, and since 9x is a lower degree than x squared, boom, we know we're completely finished.
Welcome to Section 5, Level 3 Board Exam Challenge. Example 11, Finding Missing Zeros.
You are doing absolutely great. Look at this Level 3 board exam problem. Find all remaining zeros of 2x to the fourth minus 3x cubed minus 3x squared plus 6x minus 2 if you know 2 of its zeros are root 2 and negative root 2. Okay, deep breath. What's given? A massive degree 4 polynomial and 2 known zeros. What's asked? We have to find the missing zeros. Now, do not let those square roots or that massive power of 4 intimidate you. We're going to stay calm and apply the exact same logic. Here is the truly brilliant part. Since we already know 2 zeros, root 2 and negative root 2, we just multiply their factors together. X minus root 2 times x plus root 2. That gives us x squared minus 2. Boom! We just confidently created our very own divisor. Now we perform our standard long division on that giant polynomial to get a much simpler quotient, which turns out to be 2x squared minus 3x plus 1. And look at the remainder at the bottom. It's 0. That proves we did it perfectly.
Finally, we take that shiny new quotient we just found, and we simply split the middle term to factorize it. This easily reveals the remaining 2 zeros, which are 1/2 and 1. See? By breaking a huge, scary problem into smaller, logical steps, what looked like a total nightmare became completely manageable.
All right, Section 6, quick cheat sheet, key takeaways, and a really cool surprise exam trick. We've covered a ton of ground today, so let's wrap this up. This summary box, pulled straight from our source material, is your golden ticket. It confirms literally everything we've talked about. The definitions of polynomials, the maximum number of zeros based on their visual shape, and the foundational division algorithm itself. I really want you to keep these 5 core principles highlighted in your mind. If you remember that division is just a repeating cycle and that you always stop when your remainder's power is smaller than your divisor's power, you will never ever get lost in a long division problem again.
And here is your surprise trick, specifically tying into point 5 from our summary. Let's say you just finished a grueling long division. You found your zeros, but you want to be absolutely 100% sure you're right before the exam clock runs out. You can actually verify your answers without redoing the whole division. Just use the sum of zeros formula, alpha plus beta equals negative b over a. If your zeros add up to match the coefficients in the original equation, you know for a fact you've secured full marks.
You've done incredible work today, honestly. By visualizing the math first, understanding the why instead of just memorizing the how, and practicing step by step, the math fear just disappears. With these tools, your mental checklist, and the solid cheat sheet, you are completely equipped to conquer any polynomial your exam throws at you. So the only question left is, which complex polynomial are you going to challenge yourself with next? Thanks for joining me in this explainer, and hey, happy studying.